In this module, you will learn about various concepts of object-oriented programming, including objects, classes, encapsulation, data hiding, abstraction, polymorphism, and inheritance. Advantages of object-oriented programming over earlier programming methodologies. Object-oriented programming, or OOP, is a programming methodology developed around objects rather than actions, that is, data rather than logic. Initially, a program was viewed as a logical procedure that took data as an input, processed it, and produced output. But after the introduction of OOP, a problem is now looked in terms of objects rather than process of doing it. Before looking at object-oriented programming, let us first understand what is an object. An object can be anything that we can identify around us. It can be a person or a living or non-living thing found around us. For example, a bus, a cup, or an animal. The essence of an object-oriented model is to make programming closer to the real world and to make it a very natural way of programming. The first object-oriented programming language was Simula. Later, Java, Python, C++, Visual Basic, .NET, and Ruby were developed, and these are the most popular object-oriented programming languages today. An object-oriented programming paradigm is a model which focuses on objects and data rather than actions and logic. Basic concepts of object-oriented programming include 1. Objects, 2. Classes, 3. Encapsulation, 4. Abstraction, 5. Data hiding, 6. Polymorphism, and 7. Inheritance. Let us now look at each of these concepts in greater detail. We shall begin with objects. One of the key concepts of object-oriented programming is object. An object can be anything around us. It can be a person, a place, any activity, or any other identifiable entity. Every object has three essential characteristics. They are identity. It is the name that identifies an object. Properties. It represents the features or attributes of an object. Behavior. It signifies all the functions performed by an object. Please note that you can access the data of an object by functions associated with that object only. You cannot use the functions of one object to access the data of another object. Let us now explore the essential characteristics with an example of a mobile phone. A mobile phone is an object and is characterized with its own identity, properties, and behavior. Mobiles can be identified based on their brand names such as Nokia, Samsung, Micromax, etc. Thus, these names form the identity of a mobile phone. A mobile phone has various properties. It has a model number, color, price, and configuration. Similarly, a mobile phone can be used to perform various behavioral tasks such as clicking and storing photographs, sending and receiving messages, browsing the internet, and making calls. Another important concept of object-oriented programming is class. A class is a group of objects with same attributes and common behaviors. It is basically a blueprint to create objects. Even though an object is a key concept of OOP, it is the classes that provide an ability to generalize similar kind of objects. For the same category of objects, both the data and the functions operating on the data are bundled as a unit in a class. For example, consider Ram is a student studying in a college. Here, Ram can be treated as an individual object having an identity, property such as name, date of birth, address, class, and marks, and behavior like giving examinations. And just like Ram, there are other students who possess identity, property, and behavior. So, a student can be considered as a class as the students share common properties and behaviors. An instance of a class is called an object, and instantiation is creating new objects. By using functions or methods that belong to a class, an object can have its functionality. It must be noted that functions and variables are independent and belong to a class or object. Collectively, the fields and methods can be considered as the attributes of that class. Now, let us take the example of the class television, which is represented in the block diagram as displayed on the screen. Take a look at the block diagram of the objects created as instances of the class television. In the shown example, Samsung, Sony, and LG are all instances of the class television. All these instances are similar in the sense that all have basic features that a television should have. So, all of these are objects of the class television. The next concept that we will study about is encapsulation. Encapsulation refers to the combining of data and the functions associated with that data in a single unit. An object has to provide its users only with the essential information for manipulation without the internal details. In the previous example of the television class, you can observe that the name of the class, its properties or attributes and behaviors are all covered under one independent unit. This is the case of encapsulation implemented through the unit named class. Thus, you can simply say that encapsulation is implemented through classes. In fact, you can access data members of a class only through its member functions. Apart from these, encapsulation also keeps the data safe and secure from any external interference, thereby protecting it from any misuse. In the example of class television, the class encapsulates the data, that is, model, color, and price, and the associated functions into a single independent unit. Moving on to the next concept, data hiding. Data hiding can be defined as the mechanism of hiding the data of a class from the outside world, or to be precise, from other classes. This is performed to protect the data from any accidental or intentional access. Data hiding is implemented through classes in most of the object-oriented programming languages. In a class, Data can be public or private. Public data or functions can be accessed from anywhere, whereas private data or functions of a class cannot be accessed from outside the class. Thus, by making the members of a class private, data hiding can be easily achieved. You must note that access to the private members of a class is restricted and is only available to the member functions of the same class, whereas the public part of the object is made accessible outside the class. Another important concept in object-oriented programming is data abstraction. Data abstraction is a process of identifying and separating the essential features without including the internal details. The very essence of abstraction is that only the important information is provided to the outside world while hiding the background detail. The concept of abstraction is used by classes. Relevant data and functions that operate on data are encapsulated by a class by hiding the complex implementation details from the user. The user needs to concentrate on what a class does rather than how it does. Let us take an example of a television. The body of the television is abstraction. Inside the television box, there are numerous components such as picture tube, cable, and audio panel, which are private and so are hidden behind the public interface called body. Thus, this body is the abstraction which has separated the essential components from implementation details. You must also note that abstraction and encapsulation are complementary concepts. Encapsulation encloses the components of the object into a single unit and separate the private and public members. But through abstraction, essential behaviors of the objects are disclosed to the outside world. Thus, you can say that encapsulation is the way to implement data abstraction. Next is the concept of inheritance. Inheritance is the process of forming a new class, derived class, from an existing class called the base class. In the inherited class, the data members and the methods associated with the data are accessible. It allows the code to be reused. Let us understand this concept with the help of an example of class television. Samsung is a class in itself. It is a type of television. So you have television as the base class and Samsung as its derived class. Here, Samsung will have all the features of a television class in addition to its own characteristics. Inheritance has many advantages. Hierarchical classification helps you to derive a new class from an existing base class. The derived class can have few new attributes of itself. You can reuse the base class again and again to define new classes. Another advantage of inheritance is its transitive nature. For example, if the class Samsung inherits properties of another class television, then all derived classes of Samsung will inherit properties of the class television. Looking at all these advantages, you can consider inheritance as a very important characteristic of object-oriented programming. Next important concept in object-oriented programming is polymorphism. The word polymorphism is derived from two words, namely poly and morph, where poly means many and morph means forms. Polymorphism is the ability to use an operator or function in various forms. That means a single function or an operator behaves differently as per the data provided to them. You can achieve polymorphism in two ways, through operator overloading and through function overloading. Operator overloading is a specific case of polymorphism, where different operators have different implementations depending on their arguments. For example, print 6 plus 7 will give 13 as the output, and print hello plus world will give the output as hello world. Hence, here, the plus operator is overloaded. Function overloading is the ability to create multiple methods of the same name with different implementations. In function overloading, the function called will depend on the argument list, that is, data types and number of arguments. In this example, the function sample is overloaded. As you notice, we have three functions having the same function name sample. However, each function has different argument list. The function sample is called depending on the arguments. In function overloading, data types and the number of arguments, both together, form the function signature. For function overloading, the return types of the function are nowhere responsible, so they are also not a part of function signature. Please note that Python does not support function overloading, although languages like Java and C, C++ do. Therefore, if you run the code of three sample functions, the second sample definition will overwrite the first one. In a similar manner, the third sample definition will overwrite the second one. That means, if you call the function sample 10, 20, you will receive the following error. Reason being, Python only identifies the latest definition of the function sample that takes three arguments. Let us now understand the concept of binding. What is binding? Binding is the process of linking the function call to the function definition. It is when the function call is made, the body of the function is executed. Binding can be classified into two types, static binding and dynamic binding. In static binding, it is during compilation of the program that the linking of function call to the function definition is made. In dynamic binding, the linking of a function call to the function definition is made at the run time. It means that the code of the function that is to be linked with function call is unknown until it is executed. Thus, dynamic binding is flexible in nature. Having understood the basic concepts of object-oriented programming, let us look at the advantages of using the same. Simplicity. Since the objects in object-oriented programming are close to the real-world objects, the complexity of the program is reduced. This makes the program structure pretty clear and simple. Modifiability. In an object-oriented programming program, it is easy to make changes in the data representation or the procedures. When you make changes within a class, it does not affect any other part of a program. Extensibility and maintainability. In object-oriented programming, it is quite easy to add new features and extend the program. There is no need to modify the original base class. You can maintain the objects separately. Reusability. The objects can be reused in different programs, and the class definitions can be reused in various applications. Using inheritance feature, it is possible to define subclasses of data objects that share some or all of the main class characteristics. Security. The feature of data hiding in object-oriented programming provides greater system security and avoids unintended data corruption. When you run an instance of the class, that is, an object, the code will not accidentally access other program data, since the class defines only the data it needs to be concerned with. In this module, you have learnt that object-oriented programming, or OOP, is a programming methodology developed around objects rather than actions, that is, data rather than logic. An object can be anything around us. It can be a person, a place, any activity, or any other identifiable entity. Every object has three essential characteristics, namely identity, property, and behavior. A class is a group of objects with same attributes and common behaviors. It is basically a blueprint to create objects. Encapsulation refers to combining of data and the functions associated with that data in a single unit. Data hiding can be defined as the mechanism of hiding the data of a class from the outside world, or to be precise, from other classes. Abstraction is the process of identifying and separating the essential features without including the internal details. Inheritance is the process of forming a new class, that is, a derived class from an existing class called the base class. Binding is the process of linking the function call to the function definition. Binding can be classified into two types, namely static binding and dynamic binding. Polymorphism is the ability to use an operator or function in various forms. That is, a single function or an operator behaves differently depending upon the data provided to them. Operator overloading is a specific case of polymorphism, where different operators have different implementations depending on their arguments. Function overloading is the ability to create multiple methods of the same name with different implementations. Object-oriented programming is simple, modifiable, extendable, reusable, and secure.